This is a demonstration of our temperature ventilation project. As you can see, the servo motor is going anti-clockwise. This is because the temperature is increasing. When the temperature increases, the flap opens up to allow extra air to come through. However, when the thermistor cools down, the servo motor goes in a clockwise motion to close the flap of the ventilation box. The main component which has been used in this project to help the servo motor work efficiently in order to open the flap is the temperature sensor.
On the servo motor, there are 3 wires, brown, red and yellow. The brown wire is ground, the red wire is 5 volts and the yellow wire is control.
On the Arduino software, there's a feature which is called a serial monitor. When touching the thermistor, the temperature is increasing, as you can see on the video above. However, when taking your finger off the thermistor, the temperature starts decreasing. As you can see, the numbers are going down. This project that we created included Arduino board, breadboard circuit, USB cable to power up the Arduino, one 10K resistor, one servo motor, a cardboard box, 9 jumper wires, and one thermistor.
The figure shown above is the code which we had used during this project. The first line has a code of servo.h included. The reason as to why this line is included is due to the fact that the whole project is to do with the servo motor, and this line of code allows the program to include the whole servo library. Moving on down further the code, you can clearly see, as shown in the figure above, that in position and in ADC have been given a value of 0. The reason for this is that it has to be set as default value, so when the program does run, it overwrites these default values to the correct values. Now, as you can see from the figure above, that is something to do with a temp pin. The temp pin is technically where the temperature sensor has been linked to, and in this line of code, it has been specified that the temperature sensor pin is connected to A0. When proceeding, you get to the line where it mentions myservo.attach, and in brackets it's include the number 9. It's clear as to what this line of code is. The first part of the line, which is myservo.attach, this is the actual servo motor, and the number 9 is the pin where the servo motor is connected to. The line of serial.begin with the number 9600 simply means how quick it will initialize the connection. In this case scenario, the speed is 9600 bits per second. The next line, int value equals analog read, where the temperature pin in brackets is basically telling the program to read the temperature that it senses. The reason for this is so that it can retrieve a certain temperature and tell the program to change the position of the servo motor. Serial.print line with value in brackets allows the program to print out the value that it's retrieving from the temperature sensor. The next line has been set by the programmer. The two values, as you can observe from the figure, has 2 numbers at the beginning with the values of 515 and 610. These are the highest and lowest numbers that have been retrieved from the temperature pin. So when the temperature sensor reaches 610, the servo motor changes the position from 0 to 180 degrees.
Overall, as a group, we found this project interesting as it allowed us to test our abilities to another level, as we have never used this software before. This project included a lot of trial and error. However, it was a great learning experience as it allowed us to discover new elements of coding and allow us to build something that we have never imagined building at our time at university.